So, like Holger said, my name is Marta. I'm a developer advocate at Viverica, and PyFlink is arguably one of my favorite projects in Flink, but not necessarily the one I'm most experienced with. I was just really curious to try and build something with it. So, because this was, I think it's the only talk about PyFlink in the whole conference. I tried to make it a little bit more of like an overview of how PyFlink is evolving and how what plans the community has for it. And I have a little demo that is just kind of a set of pictures because my machine is about to die. Cool, so let's get started. So in this talk, like I was saying before, I'm going to very briefly talk about the motivation and evolution for the community to actually add a Python API to Flink. I will be walking you through very quickly about this demo that I put together and that isn't yet in a public repository for valid reasons, and also looking ahead what it can expect in the next release for the Python API. Oops. Okay. So the first question is around why adding a Python API to Flink. Well, Flink is JVM based. It's been for since forever, a bit more to the Java and Scala developers, and so it makes sense to kind of also expose the functionality of Flink beyond the JVM so that people who are not comfortable in doing Java or Scala or more low-level programming can also take advantage of building jobs that scale and that parallelize workloads like Flink can do. And on the other side, Python has a really mature and intuitive analytics stack. And the only problem with it is that if you see the libraries that most developers use these days with Python in 2020, a lot of them are older than more than 10 years older, and they don't really scale. I mean, you have, especially in the data science world these days, you have a lot of really great libraries that are built Python first. But like for example, TensorFlow, we also have TensorFlow extended, it can scale. But a lot of these still very popular libraries like Pandas or scikit-learn, they're really, really hard to scale and very hard to parallelize. So you're kind of always bound to how powerful the machine you're running Python on is, because you can only go so far. And so that's the second motivation of introducing this Python API in Flink. So you, on one side, want to give Python developers the opportunity to take advantage of everything that's great about Flink, and on the other side, you also want them to be able to distribute and scale this great analytics functionality that Python gives you, and that also kind of flexibility you can really get with Java or Scala. So over time, if you think about it, I was quite surprised because I think everyone is a bit lost in time these days. PyFlink is quite young. If you see, it was released, like Holger said, it shipped with 1.9, and that was already a year ago. But still, if you compare it to other projects, it's pretty new. And so in the first phase, in 1.9, what went out was just beta release, I think, with just stateless operations in the table API. And then in 1.10, in February this year, it got the community added support for UDFs, which really expands what you can do with Flink, because this means that you're not really restrained to to what you have in the table API, you can actually just build your own logic and implement your custom logic into these programs, which is pretty cool. And in 1.10 also, PyFlink became available in PyPy, which means that if now you want to fire up your PyCharm, you just do pip install Apache Flink. It installs like all the dependencies that it needs, and then you can get started writing a Flink program, which is pretty convenient. And in the still latest release around July, and you can see that the amount of development was already much more considerable than for the previous releases. And one of the things that also improves a lot the usability of SQL is the fact that you can now use Python UDFs in SQL DDL. So if you're using the Java table API, you can use Python UDFs as well. The support for tabular UDFs, inspecting the metrics of your UDF so you can see how they are performing as well. That wasn't possible before. And then a lot of things around integrating, making sure that PyFlink was really well integrated with pandas, which makes a big difference because then it means that you have access to all these Python libraries that I was telling you about. And yeah, also on the optimization side, Cython support. So you can Cythonize your UDFs so that they run faster. Yeah, basically. And so when I was thinking what I would like to try with PyFlink, it was really to kind of integrate it or try to experiment to do something with one of these natural language processing libraries. And one of the things that I've been wanting to do, because I do some work with the Flink community or just kind of getting a feeling for the community, and I spend a lot of time on the mailing list. And because I'm not a robot, sometimes it's a bit hard to really get a good feeling for what people are struggling with the most or what topics come up more often. So it was kind of my first thought to try and build something with PyFlink where you could just like identify the most frequent topics that are discussed in the mailing list. And I should have given this a second thought, I think, because in reality, it's really hard to do unsupervised learning on a huge amount of text data. So yeah, that's one of the reasons why my demo is kind of still in the oven, even though it works. I can't promise you that the results of the classification are very exciting. Okay, but then this is what I tried to build. So one of the other things that I wanted to try out was this new change data capture connector that doesn't really require that you deploy all Kafka and Kafka Connect. Is just like built with this embedded Debezium engine, so you can just use it like a regular connector with no other dependencies. And because I already had an instance that had the mailing list data, what I wanted to do is not only read what I already had there, but then just whenever I got new data from my integrations, then the data is naturally just streamed into Flink. So that's the reason why I'm using the change data capture connector here, just because then I can transform my static database into streams and I don't have to think about pulling it all the time. And yeah, my job can run continuously and give me continuous results. And then, like I said before, I trained LDA model. So it's basically an algorithm that takes text and just calculates the probability within the whole corpus of the text that you give it, the probability of a certain document being within a certain topic, which was exactly what I wanted. And so I think my training was a bit not very, how do you say? It wasn't very optimized because the topics that were selected, or the collection of words that were selected for me to derive topics from, were a bit weird, like you will see in a little bit. And so for that, I used GenSim and SpaCy, which are two natural language processing libraries in Python. And then my idea was to then use this model and then pass these dependencies or these libraries to PyFlink, so that then I could classify my streams as they came in. I could just use a UDF that would parse the topic of each message, and then would clean it, feed it to the model, and then get a classification out of it. And and then after in PyFlink, I'm not really doing like what you will see is just like very basic transformation. Then I just wanted to really get the topics out of the messages, and then just sync it again to the same instance, but this time using the JDBC connector. And then I just plugged in superset, mostly because I was tired of Elasticsearch. No, and I just not Elasticsearch, Kibana. It's another thing that I really wanted to try for a long time. So that was kind of the motivation behind this technical architecture thing. Okay, so what we want to do, like I said, is just we want to receive the streams of data from the user mailing list, and we want to feed it to PyFlink. We want to apply a UDF that will classify each incoming message according to whatever topic is more relevant according to the model. And then we will submit a job so that Flink can kind of munch the whole thing and output or sync the results to my Postgres instance, and then we can check some very basic visualizations on superset. So the first thing that we need to do, and I don't know how many people are familiar already with the table API, but because PyFlink is just basically a wrapper around the Java table API. It's if you have used the table API before, you will know pretty easily how to use PyFlink, because everything is kind of kept coherent, and so you have the same methods. So it's basically the same thing, but then you have the advantage of using Python and being able to use other things in the Python ecosystem. So to define a table, you can do it in two ways. The recommended, and I think most straightforward way, is just to use SQL DDL. So you just define a create table statement that could run in any database. And like you see here, I don't think you can see my pointer, but we are using the Postgres CDC connector, then just passing the connector properties of the database that we are connecting to. The table name and the schema that we want to monitor with this CDC connector. And then we just do execute SQL, and then we create this table. I mean, I'm showing you chunks of the file that is actually going to be submitted to the cluster. So next, we need to do our UDF that is going to implement the logic that we want for the classification. And for this, in PyFlink, you can just use this decorator at UDF, and then you specify as an argument your input types. Here we are passing the topic of the message, so it's a string. And what we will get back is also a string that is the most relevant topic within that message that we are processing. And so here, LDA model. Here, in the first line, I'm loading the model that I told you about that I trained, and with tokenizer is also a class that I created to clean the input, so that because the model only takes vectorized strings, so tokenizer does all the pre-processing that I need so that the model will accept will accept the input. And then I'm just getting back basically the most relevant topic, because what you get when you feed something to this model is you get like a whole list or a whole matrix of distribution of probabilities of words and the topics. And so I just wanted the most relevant topic for each message. And next, what you need to do now that you have your sources, your table sources reading from Postgres continuously, you defined, what did I talk about before? Yeah, we defined our logic to actually classify the things that we were seeing. And so now what we need to do is just create our query, basically. And this is, again, you can kind of choose how you express this. So you can use this kind of syntax that you have here, or you could also just write a regular SQL query and then feed it to the table environment in the same way. So it really is kind of your choice how you want to. I tend to gravitate towards SQL all the time. So here I made an effort to actually show the other way that it can do it as well. So, but if you see what I'm doing here is just I'm selecting from this CDC table that I created. I'm filtering by messages that I'm filtering out the messages that have a null subject, mainly because they were breaking my code. And then I'm just selecting message ID, a date, the name, and then here you see the class topic is the UDF that I registered before. So I just pass the message subject to it, and it will return basically the classification that I'm looking for. And and then we just insert to the sync table that is defined here. So here I'm using the JDBC connector, like I said before, and this is basically just a table that would be like the last rest for the data. And one thing that I didn't mention, but that does happen in PyFlink, is that the connectors are Java dependencies. So it's you don't have Python table API connectors. You have Python wrappers for the Java connectors. So it can be a bit strange at first, but in the end, it's pretty easy to kind of just load the dependencies and not really think that much about it. You have like some methods that you can just use in the table environment itself, and then it will just put the connectors or the Java dependencies where they need to be. Okay, and next we just submit the job to the cluster. So basically the only thing here, if you see, I'm submitting a job that is defined like this file that I was showing you is pipeline.py, and then I had to specify two things. One is PyArchives, which is it's a directory that contains my model, and the model is not just a model; it's like 4 files. It's the dictionary and other things that are necessary to make this work. And also, what I was telling you about the tokenizer, which is the class that does the cleaning, basically. And you need to pass them on, because if your UDF is running distributed, then all the task managers that are handling your UDF need to have these dependencies and need to be able to access these files. So that's mainly the reason why you have to pass this. And success. job running. So that's good. And yeah, and this job, like I said, because we have a streaming source, and we are just using the stream table environment, this job will run forever until we just cancel it. And what should have happened now is that we went through the whole process of reading from source, transforming the data, using the UDF, syncing the data to Postgres again. And then I just plugged Superset on top. It's also an open source project for visualization. And I just did two very basic charts. One was like for last week, what was the most popular topic, or what were the most popular topics last week. And the winner was number 9. So I went to check what words were in number 9. And yeah, I mean, Flink issue, source, latency, progress could be something related to watermarks or to back pressure or something like that. So it's not super clear, and I will fault my model that I assume I badly trained. But I thought that it was really interesting to kind of look at this. And also the other visualization that you have is just the user in the community that is involved in more different topics last week. And that's the guy who takes a crown is Roman, who is actually my colleague at Bavarica. So nice. Yeah, and that's basically it for what I try to implement. I want to improve some things before I put it out on GitHub, and I will also write something about it. Yeah, and so I think in a couple of weeks we will have the feature freeze for Flink 112. And again, there are a bunch of really relevant new features for PyFlink. I think the biggest feature is that you will also now be able to use the data stream API with PyFlink. So like I said before, you could only use the table API, or PyFlink was based on the table API, but now we will also be exposed, or you will also be able to write data stream API jobs in Python. You will also be able to run PyFlink on Kubernetes. We will have aggregate user-defined functions, and also aggregate pandas-defined functions. And there will be also a table API DSL in the same way that there's a Java DSL for the table API. There will also be something for the Python users, which is pretty handy. Yeah, and in a nutshell, I think I'm over time a little bit, but just basically PyFlink, if you've never heard about it, it's just unified API. You can do batch and streaming in a unified way with basically the same code. You don't need to make a lot of changes, and you can run both batch and streaming workloads. It has SQL integration because it's based on a table API. It also integrates pretty well with pandas, and this allows you to do a lot of the things that I was trying to do, so like train models and do a bit more data science-y things, and really take advantage of this huge ecosystem that Python has for analytics. And yeah, you can, it natively supports a really large set of operations, so you can do very complex joins, windowing, complex event processing, and Flink will just kind of take the load for you, and you don't really have to think too much about things like state management and this kind of stuff that is really nice about a higher level API. Yeah, you can basically connect to anything that there's a connector for, and for PyFlink, anything that is supported in the table API, you can also use with PyFlink. A bunch of formats, also things that are pretty common in data science, when you have like still some directory with like really big CSV files or something like that, you can use it with PyFlink. There's a machine learning library in the making. For now, there's only kind of like the skeleton pipeline API. You can use it, but it's a bit rough yet. So you have no algorithms implemented yet, but this is a work in progress. And one thing that is also really nice is that you can use PyFlink also with notebooks. So Apache Zeppelin is a really cool notebook. It has a bunch of interpreters for Flink, actually, but you can also use it with PyFlink. And that's it. Thank you so much for listening to me on overtime.